Accessories. Manual. Standard block. Eraser. Quick measuring bracket. Hexagon wrench. Host. Horizontal flow line. Power cord. Communication line. Steering shorts. Dropper. Goggles. Tissue. Waste bottle. Suction bottle. Solution. Bracket assembly introduction. Marble platform. Column. Fast guide beam. Handle. Beam. Wool block. Hexagon wrench. Assembling the measuring bracket. Unscrew the screws on the pillar. Then put the screws into the bottom plate. Screw on the pillar. Then use the hexagonal wrench to tighten the column and the base plate to connect them. Next, assemble the crossbeam and quick guide beam. First, unscrew the screws on the quick guide beam. Then install the crossbeam. The large hole on the beam faces outward. The screws are passed through the small holes on the beam and aligned with the hexagonal wrench to tighten them. The holes on the crossbeam 20 need to be aligned with the holes on the guide beam. Then tighten the screws with the hexagonal wrench. It's installed like this. Insert the beam into the column. After adjusting to the appropriate position, tighten the nut at the back. Next, installing the handle. Put on the V-block bracket. This is the cathode head. It also functions as a top wire. The electrolysis cup is above. Below is the rubber probe. When using, lower the beam to the appropriate position. Then just tighten the set screw. After the test is completed, loosen the top screw. The handle will pop up automatically. Connect the lines. Insert the cross-flow line into the cross-flow source position. Next, connect the stirring circle. Just plug it in. Connect computer communication cable. Insert the aviation plug to the bottom. Thread locking. Plug one end of the power cord into the T-shaped power socket. Next, insert the cross-flow line emergency head into the emergency conductive head. Just plug it in. Then plug the computer communication cable into the computer USB port. Software installation step 1. Install the driver first. Click Next. Select the first. Click Next. Next step. Select installation complete. Click Install. Click OK. Step 2. Install files with the MSI extension. Next. Next. Close the software. After installation, first, go to the device manager to check the port number. After correct connection and installation, you can see that the serial port number of the current port is COM3. If the connection is wrong, a yellow exclamation mark will be displayed. You need to reinstall the driver. Next, remember the current port number and open the software to set up the measurement. Select serial port settings. Select the corresponding serial port number from the drop-down menu to apply. Back to thickness measurement. Click to start collecting. If the COM number does not exist, the hardware is not connected properly. Need to check line connection. Now it's a normal state. Host panel introduction. On the left is the thermal printer. No ribbon replacement required. Just change the printing paper. Open the lid. Install 57x30 printing paper. Pull the paper roll upwards a little. Then put the lid on. The light is on, indicating that the paper is loaded correctly. The middle is the display area. In microns. 10 and below show 3 digits after the decimal point. That's a resolution of 0.001 microns. 10 and above display 2 digits after the decimal point. The green part on the right is the type of coating. 0 is copper with nickel plating. 1 is decorative chrome. 2 is copper for non-zinc alloys. 3 is galvanized. 4 is chrome plating. 5 is tinned. -1 is multi-layer nickel. 7 is silver plated. 8 is gold plated. 9 is zinc alloy copper plating. 10 for hard chrome decorative chrome. 11 is nickel plated iron. The yellow area is the functional area, including printing, calibration, reset, fast and slow. How to select is detailed on page 11 of the manual. Here, the sampling diameter should correspond to the diameter of the probe clamps on the bracket. There is a digital mark on the probe. Multi-layer plating means that multiple coating test results can be printed on one test result. Clear means clearing the current selection, or returning to the previous layer and setting, pass, etc. Next comes the testing phase. Take the battery case as an example. Since the workpiece is relatively small, we can use a metal plate as an aid. Loosen the rear nut. Adjust the bracket to the appropriate position. Ensure that the workpiece test point is in parallel contact with the rubber probe. Apply appropriate pressure. Too much pressure can deform the probe. Introduce errors. Then, tighten the front nut workpiece. It should not move when pulled gently. Ensure that the anode clip is securely attached. Add 1.5 to 2 milliliters of iron nickel plating solution. Do not exceed 2 milliliters of solution. Repeatedly squeeze and release the pipette to aspirate and dispense. If the solution is discolored or appears contaminated, the solution needs to be drawn up first. Re-add 1.5 to 2 ml of solution. Repeat blowing and sucking 2 to 3 times. Ensure all bubbles at the bottom are broken up. Insert the stirring head into the electrolysis cell. Flat. The current bracket is equipped with a 2.5 mm probe. For single coating testing, the key sequence is measure, fast, element key, probe, run. Click measure. Fast button, nickel coating. The current sampling diameter is selected as 2.5. Then click run. After the measurement, we can see that the thickness of the nickel layer is 1.046 microns. Press the print button to print the test results. Next, clean up. Lift the stirring head. Firmly and repeatedly compress the plastic tubing. Empty the tube by squeezing out the liquid. Wipe away the waste liquid with paper towels. Waste liquid bottle. Suck out the residual liquid in the electrolysis cup by squeezing it flat and then rounding it. If it is not clean once, you can repeat it several times. Loosen the front nut. Remove the battery case. You can see that the nickel layer has been electrolyzed. Exposed iron substrate. Next, test the chrome plating, multi-layer nickel plating, and copper plating on the plastic parts. Wipe off any dirt on the surface before testing to avoid affecting the measurement. Next, place the workpiece's test surface flat. Apply moderate downward pressure on the handle to bring the test point into parallel contact with the rubber probe. Lock nut. The workpiece should not move when pulled gently. Attach the anode clip. Add 1.5 to 2 milliliters of the solution. Repeatedly squeeze the dropper bulb. Rely on the impact force to disperse the bubbles at the bottom. No bubbles should form at the bottom of the beaker. Simultaneously, check the bottom for any signs of leakage. If there is leakage, the solution needs to be completely drained before reclamping. The order of multi-layer test buttons is measure, speed, multi-layer, kinds of plating, probe, run, measure, slow, decorative chrome 1, sampling diameter 2.5, run. Note, there is no need to insert the stirring head when testing the chromium layer of the current workpiece. Click on the computer to start collecting. End of test. The thickness of the chromium layer is 0.34 microns. Then suck up the waste liquid. Flatten the waste liquid bottle and put it in. Then round it up. If it is not clean once, you can vacuum it twice more. Press the print button to print the results. Next, to test multi-layer nickel, you need to clean the electrolytic cup with clean water. Then add multiple layers of nickel solution. Squeeze straw. Blow and suck repeatedly. Rely on the impact force to disperse the bubbles at the bottom. Ensure the solution makes full contact with the coating. Simultaneously, check the bottom for any signs of leakage. Then add the stirring head. Click clear. Measurement, slow speed, multi-layer nickel, run. Clear the dotted line on the computer first. Press run on the host. Computer endpoint starts collecting data. Multi-layer nickel testing completed. The following step involves measuring the potential difference across the multi-layer nickel coating. Use the left mouse button to select a relatively uniform area. Release the left mouse button to automatically zoom in on the selected area. Click to stop collecting. Entering the multi-layer nickel sector. First, we can see that there is a clear potential difference between the layers. 0.2 to 0.92 is one level. It belongs to the nickel ceiling. 2.92 to 10.2 can be considered as bright nickel. 10.2 to the end belongs to semi-bright nickel. Next, thickness analysis. Select 0.2 to 0.86 for nickel peak thickness to get the corresponding thickness. Next is bright nickel. The end of the nickel peak is the beginning of bright nickel from 2.86 to the middle of the slope. It is about 10, and the thickness of the bright surface is selected. The thickness of the semi-bright surface is selected from 10.21 to the end to obtain the corresponding thickness. Then analyze the potential difference between the bright surface and the semi-bright surface. When selecting the potential difference, be sure not to select noise. To find a more suitable position, take the connected layers. The first bright nickel potential appears. Then take the potential of the semi-bright surface. Measure from the lower edge at the bright nickel peak. Measure from the upper edge at the semi-bright nickel peak. This will reveal the potential difference. It's 91.11. If you need to output a report, click Report Export. Pick up the stirring head. Expel the waste liquid by squeezing the tubing. Then wipe it dry. Aspirate the remaining liquid with a waste bottle. Flatten the waste liquid bottle and put it in. Then round it. Rely on pressure to suck up waste liquid. If you can't finish it in one time, you can take more times. In order to more accurately measure the thickness of the copper layer, it is necessary to remove the nickel layer deposited on the wall of the electrolytic cup and the nickel residue on the copper surface. Add copper nickel plating solution. 3. Electrolytic nickel residue. Print out the multi-layer nickel test results first. Direct click run. Electrolytic nickel residue. After electrolysis is completed, if the measured thickness is 0.5 microns or less, no need to count. Measuring thickness above 0.5 microns, nickel layer thickness needs to be taken into account. Start testing the copper layer. Note, the nickel layer solution is acidic. The copper layer solution is alkaline. The two will neutralize the acid and base, so you can take a little coating solution to pre-wash and neutralize, then absorb the potion. Then add 1.5 to 2 milliliters of copper plating solution. Do not exceed 2 mol. Blow and suck repeatedly. Rely on the impact force to disperse the bubbles at the bottom. Ensure the solution makes full contact with the copper surface. Note, it is necessary to observe from above looking downward. The copper surface must be visible to perform the copper measurement. If you don't see copper, you can't measure copper. Otherwise, copper results are inaccurate. Then put the stirring head. Click clear, measure, fast, copper 2, run. End of measurement. The copper thickness is 29.6 microns. Lift the stirring head and wipe away the residual liquid in the tube. Use the waste liquid bottle to suck out the waste liquid in the electrolysis cup. Loosen the front nut. Remove the workpiece. Wipe away any residual liquid on the surface of the workpiece. It can be seen that the coating on the surface of the workpiece has been electrolyzed, exposing the underlying substrate.